Welcome to this additional video about how to use Steve's Factory Manager to automate the Applied Energetics 2 Inscribers. This continues on from the work I was doing in the ModSuace 2 video, where I automated the puddle and the charger. And I was about to start doing the inscribers. However, due to how long it takes to do the inscribers, I thought I'd split it into a separate video so that unless you actually want to know the full detail on how to do it, you don't have to watch it. So this video is really a breakdown on what I was thinking and how I went through the process of creating the automation, and should give you some hints on how to do it yourself. So on that note, let's get started. Okay, so to create a command group for the inscribers, and this is going to be the really bulky one. Probably have to break it into multiple groups. So what we'll do is the first thing we'll do is create a trigger, because everything you do needs to start with trigger. I'll just give a quick breakdown. This is how often to run it. So the minimum you can go is 1 second, but of course you could go 10 seconds and all that stuff, depending on how often you want to do things. In this case, we'll set it to 1 second. I'll probably change it later when we've got enough and we're not using it as often. Your connections determine what type of thing you're doing. So most of the time it's on the interval, which is of course what your interval tab, the interval piece at the top is for. Redstone controlled is if you send a redstone signal to it, and that will change, give you a whole bunch of other options. And you've got your bug detector or your block update detector. So if a block changes, for example, a furnace turns off or on, it'll trigger an event. You could use that, of course, to pick up on, well, the furnace is finished. So you could then, okay, the furnace is finished, I'll take the item out of the furnace and stick it into whatever's next. In most cases, we'll just use interval. We will need to create a condition. So our condition in this case is it's an if statement. So you're basically going, if this inventory contains X, Y, and Z, then go into this. Then go into this branch, otherwise go into that branch. So we're going to go, in this case, we need to have the presses available. So that's not really what I want. Let's try inscriber. That should give us everything. So we need to have, yeah, we'll make the silicone first. I'll rearrange these probably as we go. We also need, we need to have an inscriber available, a press available. We also need to have some silicone. Now, it doesn't give you a useful thing. I think that's the silicone we need there. So in order to make it, we need the silicone and then the silicone and the press to go with it. And if that condition is true, then we will go down the input path, which is here. And we'll say from the chest, position of the chest, we want to grab the inscriber again. And we grab the silicone press. And we will get, actually, let's not do it that way. Let's go cancel that. So right click on that, click delete. We'll just blacklist everything so that it just pulls, it will pull everything that's not listed here. And we will create an output. We need 2 outputs, one for the top, one for the bottom. So we will put it into the inscriber. Wish these had icons that make it so much easier. Is that what I want to do? Yep. This is a very basic idea. So we're going to put our press at the top. So we whitelist in this case, and we're looking for inscriber. Where is it? The silicone press. And we make it so it only can put one at a time. It shouldn't, in theory, matter because it will only accept one, but I have had it do strange things in the past. We'll also create an output which places into the inscriber, and it needs to go in the side, so south, north, east, west doesn't really matter. And we'll whitelist in Silicone. There's that one there. Once again, we'll just set it to be 1, just to make sure it only ever takes 1 in there. And I'll just make sure I did it there. Cool. So that will basically make a silicone piece. What I'm thinking we'll also do though, I think I need to create a group here while I'm thinking about it. So let's create a group, command group. And we'll just call this one Silicone. What are they called? Silicone. Let's call it Silicone for now. We need to connect all these up so we can shift them in. Let me just move that over to there. I'm going to set that out of the way. So it's on true, it does that input. So it takes anything from the chest, sticks the press in the top, and then in the bottom. And just to make it easy to understand what we're doing, this is the press. And this is the item. Now I call it item under the theory that if you're looking at this group, you'll know what it's on about. I actually don't want to connect that up. So let's shift and click on there, drag it into there. So put that there, and then we create a group node. Now what a group node does is it makes it as a joiner between the various things. Just because I've got them in command groups, it makes it a lot easier to break them into sections, but of course you need to be able to interact with the outside of the group, and that's what this does. So you've got 2 modes. In this case, we'll make this an input. And if we go back here, you'll see that the silicone now has an input node, and if you name it, it actually will, that's what we'll show there instead of node. And there's also a group node for an output. So in this case, we want to set it to output, and this is the false condition. Okay, and we'll rename this on here to be false. No. Silicone or press. Okay, so if we go back to here, you'll now see that at the bottom there's no silicone or press, and of course there's node widths, and node is just our generic input, so I haven't given it a name. And that then allows us to actually join these together, so we can go like that. And that way, the very first thing it will do is it'll try and create silicone. Now, I've just realized this is not what I normally do, so I'm going to create a variable. 2 variables, actually. I don't remember where they are. Container variable. I need 2 of them. So, the first variable, this is going to be our current inscriber. And we'll set it to the red color and leave it as local. And this is what we use for our ifs, our for each in a second. So we just leave all those the same. This one here, which is the white variable, we're going to call inscribers. Now initially this is not actually going to make any sense because we've only got one inscriber. We don't really need to worry about container types, this is just filtering down your lists. But we want to select our inscriber from here. The connection is just whether it's a declaration or standard. We're not incrementing or changing things around, so we can leave those the same. So what you do here is when you've got multiple inscribers, just click all your inscribers, and then the code we're going to put in will loop through each of the inscribers. So what we're going to do is move that down to there, and we will create a for each loop. And this is where these two variables come into play. So we're going to put this over here, tidy it up a little bit. Put that there. So for every 1 second, go into the for each loop. And we're going to use our variables. So as you can see, we've got a list. Now the list is the inscribers you're using. So because I've named the white channel here as inscribers, it shows inscribers, but it's actually quite easy to pick up what you're looking at. And of course the orange isn't labeled, but this is the element. So this is the element we're going to be changing. And we used a red, so it's current inscriber. And this is the item that will change. So when you're working on your inventories later on, you want to set them to the red. And we basically just want to go, it doesn't really matter, you can change these around, so you can go cable order, randomize order, or just a standard. Standard is the order it's defined, cable order is the order it's shown on the cable, and random will just choose a random one and an order, but we'll loop for all of them anyway. I don't know what use all does. I'm assuming that will do, it'll go for all of them. I don't know what it does if it doesn't. I'm assuming this does something, but I've never really used it. I just always leave it all ticked. And I'm actually going to set one more variable because I always seem to need it because I move things around and it gets a bit confusing. So I'm just going to call this one here. This is input chest. And we'll set it to the, actually, yeah, we'll make it green. Yep, perfect. Container types, the container is the chest. And I'll make one more, just so it's really easy to read later on, even though it's the same variable. It allows you to, sorry, not easy to read, easy to modify later on. So this is your output chest. So this is where things will go afterwards. So boink, we change our color, we'll make it the brown color that's there. And once again, it's our jungle chest. Okay, so we could go through and change all the other ones that we wanted to. So we're going to just modify the silicone again. So the condition here is going to change. So instead of being the input chest, or the jungle chest, we want it to be if the items are in the input chest. So all these items have to be in there. So those two have to be in there for it to apply. The input, or once again, we change get rid of that. Everything else stays the same. What we're just saying though is just use a variable instead. And the press, this is where things get a little bit, this is where we're putting the item in there. So instead of selecting the inscriber, we're going to select the current inscriber, which means when it's going through the loop, if it's on inscriber number 1, it'll place the item into inscriber number 1. If it's on inscriber number 2, then it'll place the item into inscriber number 2. And as you're looping through it, it will make it a lot more easier for it to do things. And it could do 6 inscribers, 10 inscribers, 100 inscribers, it won't matter. We'll just do the same thing here as well. So untick that, go to variables, current inscriber. Okay, so not a major change to what we've already set up. It's just basically using a variable. So then we join this up. So this is your for each. So you come in here, and then for each of the items in there, and we'll just break that up a little bit by right-clicking and dragging to there, create a nice little node, just so it looks a bit tidier than what was there, because otherwise it goes down on an angle. This means nothing except for making things look pretty, in other words. And then the output section here is when you've finished looping, go onto this piece of code. We probably won't use this in this case, just because we'll go for the silicone and so on and so forth. And I probably won't do silicone by like this, but I'm just setting it up initially. So we'll create another, the same thing again. We'll create, I saw one of these, but it copied. There's actually a copy button. I think that might have been a modification though. Yeah, looks like it's a modification. That's a shame. It's really nice to have a copy, be able to copy the item. So we'll call this one here, we will call calculation. And of course, we need to create two nodes, one node, two nodes. And of course, as I said before, these are input output. So we just need a node like that. And this is no press or item. Connection is output. We will of course need a condition, which will go here. And our false condition sends us down to there. Yes, I know that's not silly. We'll need an input. And we'll pre-configure this because it's going to be the same every time. So this is going to be our press. In fact, I'll configure that a little bit too. It's on the input chest. I always click on there, but I've got to remember to go into variables. It's our input chest, has to have it. The target is the up position. Oh, yes, that's right. And we require a inscriber, and it's the calculation one. So where's the calculation? Calculation presses there. And we'll add the other item in a second because I can't remember what they are. So it's pre-configuring this stuff. The inventory, once again, is the input chest. The target is the up position. And the item is the... What am I on about? No, it's not. It's a blacklist because we want to take everything out. Yep. So you take that from your chest, create one output, two outputs. One output goes there, other output goes under. And what will actually happen is that they can't use this output, it flows onto the next output. So you can keep putting outputs and inputs and it will just collect the items together. This one here, of course, is going to be our current inscriber. The target is going to be the up position. And the whitelist in this case is going to be the inscriber, which is the calculation press. Once again, we'll set it to only do one. And our output will have something else in it in a moment. Once again, it'd be really nice to be able to copy these things. And we can join those together. So it'll basically say if there's no silicone press, then go onto the calculation press. And as you can see, that looks actually reasonably tidy compared to having it all on one screen or one group. So what we need to know is what is involved. Right click on that. I should have left that up actually. Calculation. Processor. Is it the processor we know? Printed calculation circuit. That one. Okay, so the printed calculation circuit, it requires a pure Civix quartz crystal. So that's the other thing we need to add into the bottom one of that. Go into here, content, output. Did I set that up? No. Yes, it did. Okay. Self. Just double check that because I have a feeling I didn't. There we go. And we are looking for pure C. Hopefully that will find it. There it is. How did I get a bat in here? Once again, we set one there. So we've got our output. We've set that up. Whitelist. Yep. So that one there is ready to go. So we place that into there, and into there, and into there, and into there. So now, of course, that's setting up a calculation. press. Now this is only going to create the basic piece. I haven't done the processor piece. And that's why I said I probably actually won't connect these up in the same way, because what I normally do is say if I've got any one of these, then go down this path, because the process of joining the circuits together is the same every time. You just need to have a silicone first. So what I'll do that now. Actually, let's. Oh, that's really annoying. I hate how it does that. So put that up there. We'll move that down to here, and there's that bat again. Place that there, like that, and we'll put that there. Or do I want to do a different way? I might put a condition in actually. Let's put a condition in. Every time I do this, I do it slightly differently, but it's normally the same concept really. So in this case, what we'll do is we'll put a condition in, which is inventories. Now I actually don't have a temporary chest. We'll probably use the input chest, maybe. Yeah, we'll do the input chest. The target is the up position, because of course chests don't have a side, aren't sided, so it doesn't matter. Items, in this case, it's actually at if any, and we were looking for all the not inscribers, they're called processors, I think. Just double check that. No, it's circuit. Okay. So, circuit. Make it do that, not a problem. No, because I can't spell circuit apparently. Should have stuck what I had. Look at that. So, printed calculation circuit. So if it's any one of these, so we go one there, or one there. So if we've got any of the circuits in there, then now one of the things that would be nice to say, if any one of these and one of those, not quite as easy, but we can assume that we've got that point. So what we'll do is we'll put that here, and we'll join that one up there with our little thing like that, alright? So if it's got any one of those, then it will actually go down this path over here. And we'll put this here. So if we've got a circuit, yeah, if any one of those circuits is there, then we go down this path. Yeah. So if it doesn't, then we'll go in the calculation path. This will mean that once we've printed a circuit, we'll get the processor up really quickly because it will focus on that first. So we've done the calculation. We also need to create another group, which is for the engineering. And it's pretty much the same thing again. Once again, I'd love to be able to copy. So we create two group nodes, one for input, one for output. We don't need to worry about changing that one there. We'll put that there. This one here becomes an output node. And once again, we'll just call it no press or item. Now the reason I've got a check for the press is if you have got multiple inscribers, you could have 10 inscribers, but only 2 presses. So this is just making sure that we do have the presses available before we try and make the item. Otherwise, of course, it will sit there and wait for it. So we have a condition. Oh, actually, something I forgot to tell you. Let me just go back and fix that while I'm thinking about it. We need to add, what was it I was saying here? Pure service quartz crystal. So we need to add that to our condition, don't we? Otherwise, it will still go in there. Pure C. like that. Otherwise, of course, it would always go into here because it's always just about always going to be a thing in there. But so go back into here. We'll basically set it the same way again. So it's variable input chest. Now you'll note I haven't used the output chest yet, but that's a completely separate process and it's quite an easy one. So we require, once again, the inscriber. And this was the engineering press. So inscriber engineering press, yep. And while I'm here, how about I look at what the engineering press actually requires? So I go circuit. Nope, can't spell circuit. I have to learn how to spell circuit. IT. I don't know why I can't do that. You'd think I'd be able to spell circuit. Doesn't help anyway. Apparently there's a thing there. So we are looking at engineering. Engineering requires a diamond. So go back into here. Change our conditions. We are looking for a diamond. A diamond there. And then if we go into input, so once again we're going to choose our current the input chest. The target is going to be the up. Make it a blacklist because the output does the work. We set up an output. The output is going to be the current inscriber. The target is going to be the up position. The item is going to be a whitelist on the engineering press. Where is it? Engineering press. And once again, we just want to make one, just in case. And we create another output here, which is for the same thing. It's the current inscriber. The target is the self position. Once again, it doesn't really matter. White is going to be a diamond. And we say one diamond. Okay, join all these guys up. Okay. So now we can go. So the first thing we'll focus on is a calculation press. If there's anything in the chest that will make a calculation, we will do that one first. If there is nothing in the chest that does a calculation, we'll do it engineering. It'd be nice to be able to say randomize or do something like that, but there's not that option. So you just have to choose which ones are more important. And we also need to make one more group, which once again, exactly the same. Make a group, and we're looking at the logic circuit, which is a piece of gold. Okay. So once again, name it logic. Apply, go into here, create two nodes, 1 and 2. This one here becomes a. Now, in theory, this will never get used, but it's here in case you rearrange things and you think, oh, I'll have this one higher. So output, we put this over to there, put a node there. We then need our condition again. So condition, basically saying if the input chest, which is the green in the top position, has the following items. So we're looking at inscriber, and we are now making the logic press, I believe. I think it's logic. Yes. And the other thing we need is a gold ingot. Gold ingot. One gold ingot. So it has any one of those. Then we go into the input. So we go down this path and we grab from the input chest in the top position. We blacklist it, so it takes everything out, or anything that's applicable out. Create two outputs. We place the thing in the current inscriber. The target being the up position, because that's the top. The whitelist is for our inscriber again, which is, where's that logic on there? And we set it to 1. And we grab the other output. Let's go to here. Inventory, the current inscriber. Target self. Item, whitelist, gold ingot. Place it in there. Specify 1. Join it up. Now, in theory, if you really wanted to, you could set up some weird rules here to say, on output, send it to another node. And then you could do something here. It would give you 2. In fact, I'll show you what I mean. If we create another output node, so we create a output node, we'll just leave this on the node for now. You'll see now that the logic has 2 items, no press item and node. So you could go in there, you could set it so that when that happens, when it's run this path, it goes down this path, which then you could use to connect up to the process of making it, or you could connect it up to the next item. So you could go do this, then join to this, then join to that. But that to me looks a bit messy, and I'm happy to wait 1 second between making a press and going to the next step. So I don't have that set up, but you could do it if you want to. Just remember though, you've taken everything out of the input chest here. Although if you filter all your outputs out, you should be fine. But it's just something to be aware of. So we connect that up once again. So now we're saying calculation's important, engineering's next, and then logic's after that. So it'll always make calculation if it can, always make an engineering press, otherwise it will make a logic. And then of course, in this case, it gets a bit messier. So now we need to have a condition, another condition, which basically says in the input chest, in the up position, we require that we have Silicone, like that. We don't really need to set that. And redstone. Now, I don't really need to put a redstone condition here. It's just more of just ensuring that we don't create more than we actually need. So it requires all of those. So we've already checked that we've got one of the circuits coming in from here. So we join that to there. And of course that will say circuit, and then you've got to have silicone and redstone. If you don't have anything, you will have a problem because I don't have a false condition. But in most cases, what we're going to be doing is fine. We could make some sort of alert or a redstone lamp or something to say you've done something wrong here, in which case you trigger here. But I don't really need that. So as long as we've got that, sorry, I just realized I've slightly said that wrong. In this case, if we don't have that, so it's going to be, if you don't put redstone in there, it'll keep making silicone. Probably something to be aware of. Although, of course, we do have a condition in here that says about the silicone requiring the press and the silicone, so it'll wait for those to be there. If you don't have redstone in there, it'll wait. It will continue waiting because, of course, nothing will happen, and we don't have a condition here. So we'll just sit there like this one here. We just sit there and do nothing. And then the next thing we need to do is create another command group, which will sit here on our true condition. And this is make final processor. Which is going to be, once again, group node for your input. Now, it's up to you whether you want to have a condition here. In theory, you don't need one, because of course you've checked your condition here, you've checked your condition here. And same with the output node. You should never have, because you don't have a condition, you don't have an output node. But you could do it another way, and you could always do, you could do these checks before anything else. It's really a matter of thing, but I do it this way because it's just easier for me to follow it. So in this case though, we're going to go input, because once again we're just going to take everything out of there. Our input chest, which is that one there, the target up, and you can use down, up, down, left, right, doesn't really matter. We're going to blacklist it. We're going to say output into the current inscriber again, target of up, and this is where you'll whitelist your circuits, because that's what we'll have putting at the top. Once again, can't spell it. Circuit 1, 2, and 3. Okay, and specify 1, 1, and 1. Now, what that can cause is a bit of confusion because it will try and put one of each in there. It's not a maximum of the whole item, which is a little bit of a pain. I don't think there's a way of... you could use these ones here if you wanted to. You could set it so it's a bit more of a fuzzy detection, in which case it will just put those in there, which would be another possibility, and that way you don't have that confusion, but it reads fine like that. We also need another output, which is the inscriber. Target in this case will be the self, and this is your redstone. Once again, right click it, click 1, go back, we create another output, we go inventories, current inscriber, target is down. I can't remember if down is actually top or down is bottom. I'll assume it's bottom. Shouldn't really make a difference. The inscriber works either way. So whitelist this, and this is where our Silicone, this guy here, printed silicone. Once again, one of those goes into there. Now I have a funny, I'll just join those up. I have a funny feeling I've done something slightly wrong here though. Okay, oops. So that's all ready to go, so that makes you press. Once again, we're not taking anything out, so this currently won't work. Just going to check here that I've actually used, I use silicone silly. And this should actually be Silicone. Printed silicone, there we go. Yeah, because it's basically, if we don't have the printed silicone, we need to go down the false path. So we join that there. Okay, so now we've got our basics. Let's make everything. Okay, so we're going to take the items out of the chest, stick it into the inscribers. The last thing we need another trigger. We create an input. And you could do a for each if you wanted to. It is possible to do a for each. yeah, sorry. So we're going to go, but in this case, we can actually just use inscribers because it will go for all of them and check. Actually, no, let's do a for each. If you do that, it would cause a problem where it will pull all the items out if any of them are finished. So let's go current inscriber. I just had a thought. But let me. So the target is all targets. We just select everything here. We don't really mind where it comes from. We just want to take everything out. We blacklist it. And we'll stick an output. And it goes into the output chest, which is actually incorrect, but I'll get to that in a second. Okay, so what we've got here is go into all of the. Well, we'll put the for each in there. First thing is I want to create a condition. So yeah, so trigger to condition. The condition is that the current inscriber that we're working on, and let's go north. Yeah, north. Sure, don't know if it matters. If it has any one of the following items in it. So we're looking for our circuits because they need to go back into the input chest. So 1, 2, 3, and printed silicone. That also needs to go back in there. So they're pretty top priority. If any of those exist on the west side of it, which should be the output, it will probably work on north. I think I said north, didn't I? Let's deactivate that. Only choose west. It shouldn't make a difference, but I'll just do it that way just so it's more obvious to me. So if any one of those, then we want to go down the we want to go down this path, which is it's false. Then we can take those out. We want to output. What's wrong with that? No direction. Up. Putting it back in our output chest, is that right? Is that the output chest? Yes. Okay, so that's everything else, which is wrong. Well, I'll create a group, I think, just because it's easier to understand. It doesn't need to be joined to anything. So we'll get finished output. That way it's a bit obvious what it is. And I will join those up, hold down shift, drag into there, bring it over to here, click in there, drag over here. But it's probably a little easier to understand. So what was this condition again? So this condition is that we have any one of those. That's not what I want. Because everything goes back into the input chest. So if you were doing the output, if you're putting these items in the output chest, then yeah, that's what we want, but we're not. So we actually want to change this here to be our circuit processor. So if it's the calculation processor, engineering processor, or the logic processor, then we go down that path, which is it's actually false. So if it's not one of those, we go down there. Yeah. So in this case, we're going down. We're grabbing everything from the inscriber. Is that right? Everything? Yeah. So everything from the inscriber. We'll just call it get everything. Get input everything. Put that there. The big difference is the output actually shouldn't be the output chest, it should be the input chest. Because any item that comes from the items needs to go back, such as the presses, and the output, such as the raw material, needs to go back into the input chest. It's only when we don't have that we have a condition. And of course, you can't put a condition, you can't go grab the input and do a condition on it, because at that point, the actual item's no longer in there. You could say, so that allows you to do something like grab a current item. If there are more items, go down this path, which not one wants. So we'd have to have two inputs where we grab everything. Although in this case, we actually want to grab, so this is going to be once again input everything but we go inventories from the current inscriber. We can then go target, once again, select all of these. Yeah. I know I've missed out what I'm doing. So it's, what do we say? If it's west side, so we deactivate the west side. This is where things have to be tested. It's a blacklist, so grab everything but, and we stick everything into, well, actually we could do, thinking, let's actually go everything, because we can grab everything out of there and then use our conditions to be a bit more intelligent. So let's go activate west. So grab everything out of the chest. Doesn't matter what it is, just grab it. Output into the output chest. What was it doing? Output. So this is going into the output chest, yes? Yep. So target up, down, left, right. No, it doesn't matter. No sides on the chest. We want a whitelist in this case. So this is where our processes go. That's our final output. So we put all processes into the output chest. And then we create an output, which basically says everything else, just put it into the input chest. The up position, blacklist, yep. I said that the whitelist, I did. Which also means I can actually get rid of this, and that's what I was thinking. If I get rid of that, and that, we've basically built a condition in there that says if you've got the final output, stick into there. So we just need to change this though. So if it's printed silicone, printed, I can do all of them, cool. Printed, any one of the printed stuff, or that. Now the reason why we have to check for this is because it will still say there's something in there, even though it's in the middle of processing it. So if you put your item, for example, you got the press at the top, it'll let you take your press out, but the press is always going to be there. So we need to make sure that we don't take everything out while it's still processing it. So we only take it out if any one of these items are actually in there. So in the case of this, we can go interval, connect to there. We go grab everything. Did I make that error? Yep. So we change this one to output processors. Connect that up to there, ding, and ding. And that way we can still have our false thing there. Now you also can't connect this up down here because this is running on a single second. So it'll put the item in there, but the inscriber is not fast enough to actually process it in the run it's doing it. It has to be an instant output for it to work, and there's no way of getting instant output out of an inscriber. So it has to be a separate trigger or a separate run. We could potentially put it in here. So it's for each inscriber, it always does that, and that's what we're actually missing. We're missing our for each. So where was our for each? Down here somewhere. You can use the same colors, which makes it pretty easy to work with. Let's go trigger over here. For each there. And it's pretty much the same as the other one. So place that to there. Condition to there. Let's just line a little bit so it's a bit more prettier than that. So variable, we want to go from that and go back to current inscriber. Yep. So in theory, if I put the presses into the container, which I already have, as you can see, so it hasn't taken those out, but if we take a piece of gold out, it took it out, stuck it into the inscriber, and makes it, takes it out, sticks it back. Cool. We don't have any silicone on me at the moment, but we can test it in a second. So we put the flux crystal in there. It should make no difference. It should do nothing because it's not a condition. Okay. Put the silicone into the chest, and you just see it take off the stuff. It'll press it. See it happening in the background there. One printed silicone. Put some redstone in there. And logic processor. Okay, I put a diamond in there. Do the same thing. Let's put some redstone and some silicone in there as well. And then when it's ready, so you'll see it takes it off, creates the silicone, and then it takes it off and does it as well. And it should give us a engineering processor. So that automates the inscribers, and it actually is hopefully quite simple to understand. Because you're starting off here, you just go down for each of your inscribers. This is our condition of, now we could name it, so let's actually name it. So if we have a, so we could go if printed ready, so if printed ready, then on the true condition we can say we have silicone and redstone. If redstone and printed silicone. Oh, apparently we're limited on words. Okay. If read S and printed sil takes us into there. Okay. So we'll make up front a processor, otherwise we'll make silicone. Okay. Else, so the false, we make a calculation processor. If there's no press or item, then we make an engineering processor. If there's no press or item there, we then make a logic processor. So if we go back and look at this, I think, did I name this? No, I didn't. Okay. I think I've done that with the silicone, didn't I? Go back and have a look at silicone. What's the silicone I've done? Yeah, press and item. So we just do the same here, just so it's easy to spot what we're looking at. So that is press. And this is item. Now, if you wanted to, you could say the item is a, what is the item in this case? It's pure service quartz. So pure service. There's an odd service. And that way it's a bit hard to read because it doesn't quite fit. But of course you can tell it's there. And we'll just do that here as well. Just if we're going to do it one place, we should do it here. Item silicone. Back to there. Close that. Content engineering. So once again, this is the press. I'm not going to put that as an engineering press because, well, that's what we're looking at. That's the group we're looking at. You could name your node engineering, just so you've got a name at the top. But of course, it does say engineering at the bottom here. output. This is the item, which is a diamond. And then our logic, call this one press. And this one is the item, which is a gold ingot. Cool. And then we can go to the final product under here. And we just go on to outputs. So we're going to output circuit. Circuit, yeah. Output. There that one. Circuit. We are putting our redstone in there. Output redstone. And an output of silicone. Right. So now, of course, you can quickly look at that at a glance and see, that's where I'm putting that. If you need to fix it for some reason. But most of the time, it's pretty reasonable what it does. And I think that's pretty much us. I don't think we need to really cover up anything else. As I said, you could put something else down here if you wanted to. But yeah, I think that's us. Actually, one thing you might want to do is create another condition, which means we need to move all these down a little bit. Just thinking of problems I had in the past. One of the things every now and then bites me. How much room have we got in there? Just enough. So we'll put a condition in here. And this basically says the current inscriber in the up position does not already contain our inscribe calculation press, the engineering press, the logic press, the silicon press, or any one of the printed things. One of those, or one of those. And that is going to go into here. And it's a false condition. Because every now and then what it does is it seems to pick up that there is a... Oops. Oh, broke that. Let's fix that. It seems to think, oh, there's not an item in there, I'll use it anyway. And when it's... Which can be a nuisance when it's doing the final output. Because, of course, it uses that bottom slot. Otherwise, it doesn't use the bottom slot. Doesn't really have a problem. But it can be a problem for that bottom one. You could, of course, configure it to use a different inscriber if you want to, in which case it wouldn't be an issue at all. But that one condition just basically says if it's currently got anything in the top slot, ignore it. And then we require, once the get finished item has detected there's nothing in it, it will take it out, and then it can reuse it. So I think that will do for our system. If you found this video of any help at all, or you're going to use it, please do leave a like. It does help out quite a bit. And also leave a comment if you've got any suggestions or tips or things I've missed that might work better, or if you've got any questions on how it works. I'm happy to answer them. Yeah. And obviously, if you want more of these types of tips in the future, or you want to follow the ModSuace 2 series or any of the other series I've got, click the subscribe button, and yeah, you'll get future videos. But for now, bye!